Good morning! I am re-recording this video that I recorded yesterday because the previous one had no sound and I'm so sorry about that. But here we go. Introduction to rational numbers. These are some problems from your practice, and then I've got one from your quick check, I think, that I wanted to talk to you about because I thought it wasn't necessarily clear how to do them, and I just want to make sure you're good to go. So the first one that I wanted to talk about is here. The following numbers are shown on a number line. Hey, they're not shown. There is no number line. Well, let's make one, okay? And then we're going to answer the question, which number is located furthest to the right, okay? So if we don't know what a rational number is, we're going to have trouble doing all of these problems. Okay, so rational numbers, let's just go over what that is here. It says two integers written as a ratio or a fraction. Okay, so these numbers here, they're two of them are fractions. One of them's a whole number, the number 2 is a whole number, and then two of them are decimals. Okay, and decimals are fractions because we can take any decimal like 0.8. We can identify the place value of the furthest digit. This is the 10th place. And we can say that this is equal to 8 over 10. 8/10, okay? So even these decimals here are fractions. We can write them as fractions. Okay, the negative 1.99 would be negative 1 and 99 hundredths because the furthest to the right 9 is in the hundredths place. So let's go ahead and draw this number line. I'm going to make this a little thicker and change it to purple. You know, I've got a nice grid here. I might as well draw it on the grid. I do the best I can. It doesn't have to be perfect. Okay, and when you're doing these problems, it is a good idea to have some scratch paper near you. Just for problems like this where they say, look at this number line, and there's no number line. Okay. So all of my numbers are going to fit on this number line. The greatest value is 2. The smallest value is the negative 1.99. I'm going to start with that one. Okay, it's right here. It's almost at negative 2. It'd probably be even closer to the negative 2. So this will be my negative 1.99. Okay, let's do 2. That one's easy peasy. It's actually on the number line right there. Okay, negative 1/4. I get a different color here. So negative 1/4, you can think of it as negative 1 divided by 4. So negative 1 is the distance between 0 and negative 1, like that. This would be negative 1/2. So negative 1/4 would be right here. You are splitting up the distance between 0 and 1 when you look at negative 1/4. Negative 1.5. Okay, this is more negative than negative 1. That's how I'm going to think of it. Okay, it's going to be here. It's going to be halfway between negative 1 and negative 2. Let me erase that because it's messy. And just put a nice dot right here. This is negative 1 and 1/2. Okay. If I'm going too slow, you can change the speed on this video by clicking the little gear, the settings. You can put me on 1.5 speed. I'll talk real fast. Okay, positive 0.8. Let's do that one. Okay, that is 8/10. 0.8. I'm just going to kind of guesstimate that it's about here. Okay, 0.8. No, that's wrong. Did you guys see that? Look where I put it. I put it close to 2. That's not right. So here's where 0.5 would be. Oops. No worries. I'm not embarrassed. Everybody makes mistakes. There we go. All right. So that's a nice number line for me. Number lines work like a ruler, if that helps you. Now let's answer this question. Which number is located furthest to the right? The right is where positive infinity is. Okay, and so that should be the biggest number, and that's going to be 2. Maybe you knew that without drawing this whole number line, but there are a lot of questions on the quick check that have number lines, and I thought it'd be nice to look at one. All right, let's look at this next one. Jaime needs 1/3 of a cup of milk to make a sauce. What rational number can be used to represent the quantity of milk Jaime needs? Yeah, it's Jaime. Okay, so here I need my definition of rational number, which again we said fraction. And guys, I wanted to go over this because this question is easier than what people think it means. They're like, what do I do here? This is all they're asking. Right, 1/3 as a fraction. Done. That one's done. Yay. Okay, there's one more that I wanted to do. And then I'm going to show you something on the lesson intro page, I think. Unless the video is super long and I'll end it. Okay, which is a rational number? Is it this one, 1.345, or is it this one, the square root of 6? Okay, you guys, what's the square root of 6? I don't know. Well, let's do it in the calculator. Okay, so if you ever need a calculator, just open a new tab, type 2 + 2, enter. Okay, then you'll get Google's calculator. It's got square root right here. I'm going to type square root of 6. Okay, and it's got this number, okay, which is pretty wacky. Okay, and you're going to be learning this is what we call an irrational number. And it actually does not end here at the 8. The calculator is rounding it off. If you look here, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 digits. And that's when your calculator in Google starts to just say, nope, I'm done. So here's another calculator that I think will give me a few more digits. This is Desmos, it's free. So square root of 6. See, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, only 10 digits. Okay, so it looks like a different number, but it's not. It's just that neither one of these calculators is giving the whole number, because you can't, because the square root of 6 is irrational. The digits keep on going to infinity with no pattern. Okay, so if we look back at our definitions here, okay, so up here they have the definition of rational number, which we already talked about. Below it, look what they have. Repeating decimal, terminating decimal, okay? If you have one of these two things going on, that means it's rational. A repeating decimal is, you know, like if you take 1 divided by 3, 1/3, it spits out 3, 3, 3, 3, 3, 3, 3, 3, 3, and we say, oh, that's repeating, and we put a line over it. Okay, that's our repeating decimal, 1.33333333333333333. Terminating decimal, a decimal that ends at a specific value. So a little bit tricky here, because if you did these in the calculator, technically these ended, right? So just be on the lookout. If you've got 10, 12 digits that have no pattern, it's likely your calculator is just chopping that number off or rounding it. That's not terminating, not the same thing. Okay, so a terminating decimal ends at a specific value after the decimal point, like this one, 0.375. Okay, and then it ends. This is 365 thousandths. So let's go back down here and look at our numbers. If you look at 1.345, that one terminates. So that's what we want here. This guy, this is rational. All right. So that, yeah, I'm going to show you the other thing later. That's all I have today. This lesson intro has links to some games you can play. Those are optional. Okay. They're in Blooket. But anyway, that's all I have. Sorry about the other video, and I'll talk to y'all later.